When an object falls, it accelerates downwards. That's because its weight is pulling it downwards. Opposing that weight going down is its drag pushing it up. Now, the faster an object goes, the bigger its drag becomes. Eventually, the drag will equal the weight and the forces will be balanced and the object will have reached terminal velocity. Weight is a force that acts on a mass when the mass is in a gravitational field. Now, I've already made a video all about the difference between weight and mass, so why not subscribe to my channel, and that way you can easily find that on all my other videos. In both of the examples in this video, the weight of the object does not change, and that'll be true for any questions that you get. We're going to start off looking at a skydiver to see how its resultant force changes and why its resultant force changes as a skydiver falls. When a skydiver jumps out of an aeroplane, the only force acting on them is their weight. Their weight is pulling them down, so the resultant force is downwards, and the object, or the skydiver in this case, accelerates downwards. As the skydiver accelerates downwards, their speed increases, and as their speed increases, their drag increases. Their drag in this case is air resistance. Now, as their air resistance increases, the resultant force will decrease because the air resistance is opposing the weight pulling them down. Remember, the resultant force is the total of all the forces acting. Eventually, as the drag increases, it will become equal in size or magnitude to the weight. At that point, the forces are balanced and there is zero resultant force. If there's zero resultant, there's no acceleration, and the skydiver, or the object, whatever it may be, is now travelling at its fastest velocity, what we call its terminal velocity. The terminal velocity for a skydiver is around about 120 miles per hour, or 54 meters per second. That's sort of in the normal flat belly position. The only way you can increase your terminal velocity is by decreasing your drag. And you could do that by making yourself more streamlined. If a skydiver sort of goes head down and points and makes themselves really streamlined, they can probably reach about 200 miles per hour. The good news is this works the other way around too. If we increase our drag, we decrease our terminal velocity, and we can increase our drag by opening a parachute. When the parachute opens, there's a much bigger drag force upwards than there is a weight force downwards, and the skydiver therefore decelerates because there's a resultant force up. They decelerate or slow down. A lot of people think that skydivers go up when they open their parachute. Definitely not. They're going down at 120 miles an hour. They can't suddenly go up. That would be catastrophic for their body. What happens is that people who are often videoing another skydiver open their parachute, they keep falling while they're videoing, and the person who opens their parachute actually gets left behind. And it appears that they're going up. But they're not. They're still falling down. As the skydiver slows down, their drag decreases. As their drag decreases, the resultant force decreases, and eventually, when the drag is equal in size to the weight, the resultant force will be zero again, and the forces will be balanced. They're now at a much slower terminal velocity, one that's much safer to hit the ground at. Before I show you one more brief example, can I point you in the direction of my website, videoplaytoacademy.com. On there you find lots of free resources to go with this and all the videos. I also offer one-to-one lessons, and I try my best to keep them as affordable as possible. You can also support me by liking and subscribing and commenting. I love to read your comments. That helps me keep all these resources free. Right. Instead of an object falling through the air, let's imagine an object falling through a liquid. Let's take a large metal ball falling through a cylinder of oil. Just like the skydiver, the weight of the ball does not change as it goes down. The drag, however, the resistance from that liquid, the drag increases as speed increases. Once again, when the drag becomes equal to the weight, the forces are balanced and the object reaches a terminal velocity. So in any exam question about falling objects, remember these 2 points. The weight stays the same, and as speed increases, drag increases. Now watch this. Please watch this.